Okay, welcome to this lesson. It's a topic in Form 4, and we are going to look at progression. But before we proceed, let me take you through some of the success criteria. What is it that is actually required for you to get a sense in this particular topic? What is it that you are required to do? The first one, you are supposed to find the terms of an arithmetic progression. You are also supposed to find the sum of the arithmetic progression. You are supposed to apply arithmetic progression in real life situation. You are also supposed to find the terms of the geometric progression. You are supposed to find the terms of an arithmetic progression and apply geometric progression in real life situation. That's what this topic is all about. But when you look at this term, the terminology, which is called progression, and the term progression, progressions, maybe we can pluralize because we have two of them. We have the word progression comes from the word progress, where you have a list of numbers that are continuing. That's the term progression. But now when we're looking at progression, we have two types of progressions. We can look at two types of progressions. These two types of progression, we have two of them. The first one, we call it an arithmetic progression. And then the second one is what we call the geometric progression. Yeah, so these are some of the kinds of progressions. But now when we look at this, we have the symbols that are used internationally basically. When we are looking at an arithmetic progression, this one is also known as an AP. It's abbreviated as an AP, meaning arithmetic progression. And the geometric progression is also abbreviated as GP. Now, these are the two types of progressions that we currently have. But now we are going into details by looking at each one of them. So we can start with an arithmetic progression. Which is also known as I said, this one is an AP. It's abbreviated as an AP. Now, how do we understand this? So, an arithmetic progression is numbers can progress arithmetically or they can progress geometrically. But the same, an arithmetic progression can be a sequence, or it can be numbers can be in form of a series. So you need to understand all this. We have a sequence where you have a flow of numbers that are separated by commas. But now we need to understand the word arithmetic progression, where we need to understand what it means by that. So basically, we have to examine. For example, let us examine these numbers. We want to understand, let us examine these numbers, or where we have sequences. We have 1, 3, we have 5, we have 7, we have also 9. So we have B there, we have also 2, we have 4, we have 8, we have 16, we have 32. So now we can have the third sequence now to say 1, 4, 9, 16, then 25. So these are some of the sequences that we have, but now we need to understand when we talk of arithmetic progression, not all sequences that we are giving you that might be given you are said to be progressing arithmetically. So these three sequences, one of them might be an arithmetic progression, but the question is, how do we identify a sequence being an AP or being an arithmetic progression? How do we know? There is a clue. Now, let us, as I have said, that we have these numbers. We have 1, 3, 5, 7, 9 as a list of sequence. Now, before we go to that, we are saying these are sequences. But how do we actually come up with a definition of a sequence? So when we are talking of a sequence, we are talking of a list of numbers. These are a list of numbers that are actually separated by commas. So the terms in a sequence are basically separated by commas. As you can see, 1 separated from 3 by a comma, 3 and separated from 5 by a comma, and 5 separated from 7 by a comma, and 7 separated from 9 by a comma. But all these, likewise B, you see that this is a list of numbers which is a sequence. But then we said the sequence can be an arithmetic progression. Now, when we talk of an arithmetic progression, what do we actually mean? When we talk of an AP, remember I said we can use the symbol, the abbreviation, an AP. Now, an AP, we are looking at a list of, this is a sequence whereby now there is a fixed term. The difference between two consecutive numbers are giving us a fixed term. We are talking of the difference. I mean to say, when you subtract two consecutive terms, the terms that are next to each other, that's what it means by consecutive. When you subtract the difference, it means subtraction between two numbers that are next to each other. If you subtract any of the two, then you must obtain the fixed value. If the value is not fixed, then we conclude that that one, you dump that one. It's not what? An arithmetic progression. Now let us look at the first sequence, whether this one can give us the fixed value. And this fixed value in arithmetic progression, we call it the common difference. And it's basically abbreviated. We use a symbol. We denote that using a D. So now let us observe this sequence where we have an A. In the first instance, we have A where we have numbers 1, 3, 5, 7, and 9. Now let us look at the D. We have to find the common difference between two successive terms. Let us take 1 and 3 are called the successive terms. Now if we subtract 1 from 3 and not 3 from 1, we are likely to get, if we subtract, for instance, D here will be 3 minus 1, which is 2. But now let us also pick the other terms. Not only this, you can also pick 3 and 5 here. So now we are also going to see that we may have 5 minus 3, which is giving us a 2. And again here, we may pick 5 and 7. We also see that if we subtract 7 minus 2, 5, we are likely to get a 2 again. And even if we pick 9 and 7, we subtract them, we still get a 2. So therefore, the sequence A is likely an AP. It's an arithmetic progression, because we have seen that the D, the common difference, when we subtract two consecutive terms, we obtain a fixed value. And this fixed value is called a common difference, which is a D. Now let us go to the second term there, second sequence rather. Now when we look at this one, if we subtract the two consecutive numbers, we may have, for example, 4 minus 2, we get a 2. And when we have, for example, we are saying our list is, we have our B here, 2, 4, we have 8, 16, we have 32. This is the sequence now. But now we are saying the difference between the two numbers. Here, if we subtract, for instance, 4 minus 2, we are getting a 2. And if we subtract again 8 minus 4, we are getting a 4. Then here, if we subtract 16 minus 8, we are getting 8. Again, likewise, 32 minus 16, we are getting 16. So as you can see, the D here is this one, the difference, common difference. Now, when we look at this, we analyze the common difference, we see that they are totally different. It's varying. The D is varying. Therefore, we can conclude that the second sequence is not progressing arithmetically. Rather, it's a different sequence. We continue from there. Let us also analyze on D there. We see that we have another sequence, which is 1, 4, 9, 16, 25. Now again, if we get these two successive numbers or consecutive numbers, we're getting the difference, 4 minus 1, 3. And again there, 9 minus 4, we are getting a 5. So here again, common difference, we are getting a 7. And there, 25 minus 16, we are getting a 9 there. And so on. So we see that the common difference there is varying. We have 3, we have 5, we have 7, we have also 9. Now, we see that D, being a sequence, still is not progressing what? Arithmetically, because we have a fixed value which is varying. Though we have a common difference, yes, it's there. But now, this common difference is not constant, it's not fixed. So therefore, we are saying for an arithmetic sequence is supposed to be a fixed value and not varying as such. So that's how we identify a sequence being an AP or a sequence being a GP. Now, when we look at, let us now critically look at the AP now. When we look at the first sequence, we said that the first sequence, for example, the first sequence which we identified, we saw that it is 1, 3, 5, 7, and then we have also 9. Now, this sequence is purely an arithmetic progression. I have already explained, but now we'll see that how do we get from first term? These are the terms. We said that a sequence is a list of numbers that are separated by commas. That's what I said. But now, when we critically look at this sequence here, we'll see that for us, this first term here is called the first term, which is denoted, we use a symbol A. And this one is, we are saying this is the first term, and the 3 is the second term. This one is the third term. This one is the fourth term, and so forth. So this continues like that. So you will see that this common D, the D is very important. D, we found it to be a 2 from that sequence. But now, this D is of paramount as far as an AP is concerned. So what we are going to do is, how do we find the next term there? So we are going to say, all right, if we have the first term which is an A, we denote that using an A. So now, what are we going to do? We are going to say, all right, how do we get the next term there? So you see that if we add A2 to the next term, to the first term, we are getting A3, which is our next term there. So if we say, for example, 1 plus 2, we are getting the second term, which is A3. And if we add 2 to 3, we are getting the next term. 3 plus 2, we are getting the third term, which is 5. And if we add 7 plus the common difference, we get 9. And then it continues like that. So we see that we can now generate a general sense of an arithmetic progression. So generally, we can come up with a general idea on how these terms progress in an arithmetic progression. Now, for example, in general terms, an arithmetic progression progresses, or an arithmetic progression is, for example, we may have the first term. We have seen that we are adding a common difference to the previous term to get the next term. So for example, if we have our A being the first term, we add a D. In this case, we're going to come up with expressions for an arithmetic progression. So if we have an A, we are going to have an A plus D being the second term. It means this is our first term, and this one indeed is our second term. And then we can continue like that. It means the third term, we are also adding a D here. We'll say A plus D plus another D, which is yielding, which is giving us an A plus 2D, which means this is our third term. Then we can have again our fourth term, which will be A plus 3D, which is our fourth term. So we see that we progress, an arithmetic progression will progress like that. And maybe we can also have, for example, we have to see what is happening. How can we relate the common difference, the coefficient of the D and the term, the position of the term? For example, you note that if we say second term, it means the D there will have one less. We'll have a difference of, if we say second term, it means second is a 2. So it means the D will have a coefficient of 1. It's like 2 minus 1. So the D coefficient of D will be 1 less the term that we are mentioning. For example, if we say third, it means third is a 3. Now it means the D coefficient of D is a number. Coefficient a number multiplied in front of a letter like D, like here a 2. Now to find 2D, it means here we are having third term. It means it's like now we are subtracting 3 minus 1. We have a 2 there. Likewise here, if we say fourth term, it's like a D there, coefficient is 3. Now how do we find that? It's like 4 minus 1. So we can continue like that. Now, how do we come up with now we'll see that from there we can come up with the nth term now. The nth term now is born from there, where we have first term plus n minus 1 multiplied by D. So n minus 1, n is standing for the position of the term. You can first term, for example, the first term we are saying is A. If we put first term, n is number of terms. This is number of terms. And this one is first term. And this one is the common difference. Now, according to that, for example, if we want to find this formula is very, very important because it can assist us to find whatever we want, whatever number we can find, because in a sequence is possible to find if you don't have a very long list. For example, in the first place, we had a very short sequence, and to find the next term, we were not struggling. So the nth term formula can help us to solve or to find any term that we are looking for. So in this one, for example, we are saying to find the second, what to be the second term, we use that one. We have a plus n minus 1 d. Now we said if we say second, it means our n is 2. So a plus, we are n is 2 minus 1 multiplied by d, which is a plus 1. 2 minus 1 is 1 times d. So now we'll see that the expression for the second term is a plus d. That's how we do that. Now we can also, for example, we can also try to write any expression. For example, let us write an expression for the hundredth term, for example. Suppose we want to find term number 100. Okay, we want to write an expression for that. It means we'll say our nth term is equal to a plus n minus 1 d. Now our n is 100, so we are going to have a plus n is 100 minus 1 multiplied by d. So roughly we'll have a 100 minus that is 99 times d, which is a plus 99d. So this one will be an expression for the 100th term. Now, as I said, we can have an arithmetic progression, which is a sequence, and we can have an AP, which is a series. So an AP can be a series, can be, when I'm talking of, we are saying an AP can be a series or a sequence. What I mean is when you are looking at a series, you are looking at a list. This is a list of the numbers, list of numbers that are separated by commas, by plus, or by plus sign, a plus sign, which is this one. We all know a positive terminal, or a positive, we know a plus sign as we are talking about this, a cross sign. If you are looking, you go at the church, you say a cross, that's a plus sign. So now, how do we, now I said you have to differentiate between a series and a sequence, because a sequence now is a list of numbers that are separated by commas. So we have a sequence as a list of numbers that are separated by commas. For example, e.g., the examples that we have, e.g. 1, 4, 9, 16, 25. The dots here, they mean that numbers are progressing. Numbers are progressive, meaning they are continuing up to whatever value might be. So this is this one is in a sequence now. However, this one is not an arithmetic progression, but I'm just pointing out, taking this one as an example for a sequence. But if we change, e.g., if we may change a sequence to a series, then a series will be plus 4, plus 9, plus 16, plus 25. Now the same sequence has been changed to a series. So this one is no longer a sequence, but rather is a series. That's what you are supposed to understand, the distinction between the series and the sequence. That's that. Now let us look at how do we calculate this using an nth term formula, where I was trying to say how do we use the nth term to calculate the, for example, can say in the sequence, for example, -2, we have 2, 6, we have 10, we have, so it's continuous. What is the 16th? What is the 16th term? Now let us have a solution where I said we are going to use the nth term formula. The nth term formula will assist us to actually work out the solution. So we have the nth term where we have -2, 2, 6, then we have that. So this one is an arithmetic sequence. So now we know from this sequence we can now identify the terms. The -2 is taken as an A, which is the first term. And now we can find the D. The D, remember I said, we can subtract any two consecutive numbers, of which will be 2 subtract from there, which will be 6 minus 2, or the same as we can say 2 minus -2. It means this 2 now is subtracting from there. So we'll have also a minus sign in between. So this is a 4, and this now will be the same as 2, negative, we have 2. So we have 2 plus 2, 4. So you will not be indicating two numbers, but as long as you understand, you can just use two numbers here. You may use -2 and this 2, or you may opt for 6 and 10. You still get the same D there. So you are advised not to use 2, because here I have been interested with this negative. One might be skeptical to say, how possible with this? Will this one be the same? Now, if we know now the D, we have shown how the D works, how to calculate D, so we can hopefully try to calculate the 16th term. So we'll say, therefore, our nth term is found by A plus n minus 1 multiplied by D. Now, where we have nth term, we are working out the 16th. You write now, 16th term is equal to the first term we have already that, so we write -2 plus our n now is number of terms. Here we are finding the 16th term, so we write 16 minus 1 multiplied by, what is the common difference there? We already found this, which is a 4, and indeed here we have 2. Then is what remains simplification. 16 minus 1, what do we get? We get 15 multiplied by 4. Now body mass, you multiply here first. We have -2 plus, here we have what? 60. 15 times 4, we get 60. Now, since we have a minus here, remember directed numbers. This is a topic in form 4, but you cannot rule out the issue of directed numbers, where we have -2 plus 60. With this one can be rewritten as, or is the same as 60 minus 2. Note some of people may add first here, they say -62. No, that is wrong. You cannot say -62. But rather, this is the same as you subtract. This 2 subtract from that. So now this one will give us 58. So now how do you present your answer? Therefore, you say the 16th term is 58. That's how we use the nth term formula to do that. So we can calculate any term given the information. But sometimes we may have fractions. For example, let us look at the okay, so let us look at this exercise. For each of the following, sequences, find the indicated terms. The first one, we have 1, 3.5, we have 6, we have 8.5. Then here we are finding the 20th, and we have to find the 30th terms. In B, we have 1, 2.5, 4, 5.5. Then we are finding the 10th and 15th terms. So I think you have to answer these questions. So our next lesson, we will try to respond these and then provide some solutions, and then we'll go to solving some of the problems using our nth term formula. Thank you very much. For this lesson, let us stop there.